Okay, so I'm going to add all the files from the tour folder. So bounding box, St. Louis downtown, midtown contours, a clip DEM, all these guys here, add them to the file. And then also some aerial images in the NAIP folder. So I'm going to drop them all in. And what we're going to do is we're going to just use this to kind of have as a reference data frame to kind of see what information we're going to start bringing into Infraworks, so we can do our 3D modeling for in Infraworks. But just to kind of recap some of the things, some of the basics in Infraworks. If you have a DEM image here, this is basically the terrain information that once you bring into Infraworks will immediately turn into a 3D model for your site. So we're going to build a 3D model of this entire region of St. Louis, and then you can just drape on top of that ortho images that you can download of the city. And so these are just some NAIP images that I downloaded. So I'll add them all at the same time. Before we start, we need to set up a bounding box. So I just made a bounding box in ArcMap, and so this will be the extents that will define the boundaries of our Infraworks model. I have some building footprint information. So this is building footprint information that I cross-referenced with LiDAR data. So I showed that 2 weeks ago. If you open the attribute table for these data sets, you'll see at the very end there are some numbers related to elevation, building height, ground elevation. These are in meters, FYI, the building height column here. So the process of how I did this was basically explained last week, so just check the tutorial on that to know how I actually put building heights on building footprints. Then just roads, railroads, and contours. So what I'm going to do is I'm going to start setting up the Infraworks model. So in Infraworks, you want to, and there's my secret project. Infraworks, you want to click on New at the top bar up here. I want to give it a name, so we'll call this one St. Louis. I'll just call this UT tutorial for urban topographies. It asks you for a location to save your information, so I just generally say save on your computer. It's going to save automatically to your documents. And then the model extents tab, you want to check this box, it says define model extent. Then hit the button that says load extent from file. And then from there you want to navigate to the bounding box shapefile, so bbox. And then just say use data extents. You can use first polygon, but I generally use data extents because I want it to maintain its rectangular shape. And you just click OK. All right, so once it's finished, what you're going to see is a giant rectangle, and this rectangle is the same box as your bounding box in your ArcMap document in the same location. And the way you can just verify that is, honestly, just zooming out. Actually, I need to turn on the sky settings. So let me just turn that on. If you zoom out, you'll see that it's just literally located in the location that you built it. So in this case, St. Louis, it's in the St. Louis region here. That's how you know this is geographically accurate. So what we want to do now is we want to add the terrain information to this. So the way you access that is in the upper left corner, there's an orange button that has an eye on it. And if you go in there, you hit this little button that looks kind of like a bunch of squares or cubes together. And then in that row, there's this button called Data Sources. So if you click on that, it brings up a sidebar here. And this is where you begin to add your information. So for terrain information, that's a raster format. So you want to add it as a raster. So click on the raster option in the drop-down menu here, and then navigate to wherever you saved your tutorial files. And you want to add the DEM clipped, and that's just the DEM that I clipped for you guys for this tutorial. So double click on that, and then double click on it again when it's in the data sources tab here. And now what you want to do is you want to configure it as a terrain. And usually it automatically knows what it should be, so it already selected its type as terrain, as you can see in this first line here. You can set it as several other types of terrains, but terrain, this one is the only one that's going to make it 3D. And then you want to set the coordinate system. So usually the default coordinate system, that whatever pops in the first line here, is what I use first. If this configuration doesn't work, you want to edit the coordinate system in here. And the way you do that is you click on this little globe here, and you can actually search for coordinate systems the same way you would search for coordinate systems in ArcMap. But in this case, LL83, this is actually the correct one, so I'm not going to change that. And just click close and refresh. And what you get is a 3D model of the terrain of St. Louis. So that's pretty cool. Now let's add the aerial imagery. So again, you go to this data sources drop-down menu here, add a raster, because the NAIP images are all rasters. And when you have a bunch of rasters here, I add them all at the same time. So I just hold Shift and select them all at the same time, and then click Open. And then again, configure that data set by double-clicking on it. It's going to set as ground imagery, which is the right type of file type for this kind of thing, and then just leave the default coordinate system here for this particular instance, and just click close and refresh. This should work fine. Give it a second. All right, so once that finishes configuring, now you see you have basically a very generic terrain model of the city of St. Louis. So you can see it has all the topography. If you zoom in, you actually can see the topography on the site, but it also has an image draped on top of it. So now you can begin to do some cool city modeling. Now what we're going to do is we're going to add some buildings. So go to the drop-down menu, and this time we're going to add a shapefile, because we're going to add the building footprint shapefile with all the building heights associated with it already. So click on SHP. And then you want to go to click on STL Buildings Downtown. And again, this shapefile here is all it is just, well, ArcMap crashed on me. All it is just a building footprint shapefile that I cross-reference with LiDAR data to get the building heights. So double click on that. As you can see here, it doesn't know what kind of type it's going to be here. So in this case, we're going to set it as a building. And then you're going to want to set the roof height here. And so what I'm going to set it as is click on this little button right next to the units button. And then what you can do is you can set the roof height to be some attribute from the attribute table itself. So I'm going to use building height. And since the building height was in meters, you want to change this feet unit to a meter unit. So I have to hit M. And then what I'm going to do actually is, because the building height needs to be draped onto the terrain, like I want the ground elevation to touch the ground of the terrain, and I want it to be at the right elevation, you want to actually go to the source tab here, and you see there's this thing called draping options. You want to click on drape, and all it's going to do is it's going to just set the bottom elevation to be at the elevation of the ground itself, if that makes any sense. Geolocation tab here is going to set it to Missouri 83 East feet. That's what EF means, East feet. So this is actually the default coordinate system for Missouri, St. Louis region. So this is correct. It automatically knew that. And then what I'm going to do is I'm going to set a style in the style component here. So last week I showed you guys actually put like building facades onto your buildings. In this case, I won't do that. I'm just going to add a white color just for simplicity. So if you click on the little pencil right next to rule style, you can pick a bunch of building facades you can paste on, but not this time. We're just going to do white. So click OK. And then what I'm going to do is going to hit Control A to select everything in that line, copy it, and I'm going to set every single feature here to be that white color. So just paste it in the color or remove material. And then once it's all done, just click close and refresh. And if you did it correctly, you should see that there it is, St. Louis City, basically modeled in 3D. Because I used LiDAR data to cross-reference these buildings, it took me no actual physical labor. It just literally just knew how to extrude all these buildings automatically. So this is a powerful way to begin to model large swaths of land efficiently, and not like extruding one by one, building by building. This is a far superior method of doing that. Okay, so what we're going to do now is we're going to add some custom models into this. So if you see, for instance, the arch is modeled incorrectly because GIS doesn't know how to extrude buildings in any way besides vertically. So this doesn't know that it's actually like an arch. So what you can do is you can select on a feature and you can just delete it. So we're going to delete the arch. And I believe in the tutorial folder, I gave you guys some SketchUp models that I just downloaded from SketchUp Warehouse. I'm sure you guys know that resource where you can just download a lot of buildings from the United States for free. So there is an SKP file here, and add the arch.obj SketchUp file in there. Then double click on the arch feature. And what we're going to want to do is we're going to set the type to a building. You want to go to the 3D model tab here and just make sure it looks right. This is just download straight from SketchUp Warehouse, so you can find all these kind of buildings anywhere. So this looks pretty good to me. Leave the units as whatever it is for now, and we'll see if the unit is correct. Right now it's set as meters. Because this model isn't geo-referenced, we actually have to just place it manually. And so that's what this little button called interactive placing here is for. If you click on that, you can just automatically drop in a building manually onto your site. So we're just going to put it onto kind of where the arch is, kind of right there. And just double click to set it, then click close and refresh. And so that's how you put custom architecture onto your building. And so then what you can do is you can just click on the building and just manually adjust it using the gumball tool or the move tool here, just to kind of set it and rotate it to make it to kind of fit the site. You can also move it down a little bit. So this is basically how you begin to resolve some of the places where the buildings don't look realistic, but you know you have a 3D model of, say, a building that looks realistic. That's how you fix that problem. And I have one more building in there just for fun. I have Busch Stadium, so baseball. Okay, so add Busch Stadium into your model. Then double click on Busch Stadium. Set the type to a building. Check the 3D model. Okay, so in this case, I think for some reason the axes were flipped. I might have exported this from Rhino. If this happens where this is why you always want to check the model before you configure it, is because sometimes the axis is incorrect, especially if you're bringing the information straight from a program like Rhino. You want to hit the flip Y and Z button here, and this will basically set it to be correct, correctly oriented. And then again, just go back to the geolocation and click interactive placing, and let's just plop it right where Busch Stadium should be. So just kind of plop it, double click, close and refresh. There's actually the original shapefile layer for the Busch Stadium is on the bottom. This is like this little white patch here. I'm just going to delete it because I want to see the field below it. And again, you just kind of like manually adjust it to fit the site perfectly. Close enough, you know. And you can see, like, if you just take the time to kind of set that up, you can actually build a very, very good looking base model for your projects. And so we do this all the time for our work. And then again, to check to do some cool visualization, there are two tools you want to look at. First is the high visual quality settings. So in Infraworks 360, that is located in the black bar here. If you click on this conceptual view button here, there's this little gear underneath that. And with that, you can check the high visual quality box, and this turns on all the realistic shadows. And then to get the sun settings, you want to click on this little TV thing here and click on the sun and sky button here. And then you can adjust the sun settings for your model as well. So you can play with all these sliders to get a look that you like. And you can even use this for sun studies if you are interested in doing that kind of analysis. So it's extremely powerful. At the office, we find this to be very useful, especially for sun studies, because we're doing a lot of like large-scale urban design, landscape work, and this tool is extremely good at that kind of analysis. Okay, so this all looks great, but now this is good enough at this point to start actually doing some design work on the site here. So I'm going to turn up the high visual quality just so that it doesn't bog down my CPU, and I'm going to minimize Infraworks for a moment, and I'm going to go back to ArcMap, because what I want to do now is I want to set up a base Rhino file that I'm going to interface with Infraworks when I start doing my design work. So I'm going to turn on contours, I'm going to turn on the rail line, I'm going to turn on the roads, the building footprint layer, and also the bounding box. And I've shown you guys how to do this in the past, but all you do is just right click on the layer you want to export, go to Data, Export to CAD. And then you can just drag extra layers that you want to export into AutoCAD, into your Export to CAD dialog. You can leave it as DGOG 2013, and then go to output file. I'm going to save it on my desktop, and I'll call this one base map STL, whatever. You always want to go to your environments tab when you're exporting to CAD and make sure the output coordinates are set to same as display, basically forcing it to inherit the feet coordinate system so that the units are in feet. And then go to cartography, set same as display. Then click OK, click OK. It's going to export. So once it's done exporting, you can just turn off the export layer, minimize that, go to Rhino, and type in import, then bring in your base map STL. And again, the Rhino file was already set to feet, so this should come in correctly, and I can always double check that by going into say a plan view and kind of measuring the distance between contours. In this case, the distance between contours is 10 feet. So I'm just going to analyze distance, and I'm just going to kind of eyeball it here. It's 10 feet basically, so this worked correctly. So now you have your base Rhino file in in Rhino. Now what I'm going to do is I'm going to teach you guys a technique that I think is extremely important, especially if you're going to start to do work between various programs. The problem with exporting CAD layers into Rhino is that the units are geographically accurate, but that means the coordinates for, say, this point here, so the vertices of this building are like really, really big. It's really unwieldy and really big, and as a result, if you do some 3D modeling in this environment, let's say, I don't know, let's just build a random box or something and go to shaded view. Well, it doesn't really, it's okay with rectangular geometry, but for more crazy geometry, what happens is that it sometimes begins to have a flickering look. It looks like the geometry is broken, and that's simply because the units of the coordinates of all the geometry features are just way too big. So what we need to do is we actually need to move this entire model as close as possible to the 0, 0, 0 origin as possible. And what this is going to do is it's basically going to make your modeling process a lot smoother, a lot cleaner, and you're not going to see as much artifacting and errors that you would normally see. So what we need to do is we need to set up what's known as a translation vector. You don't want to move it to 0, 0, 0 and forget the translation units. You want to remember those units. So I'm going to use Grasshopper, and you don't have to use Grasshopper for this, but I use this technique just because I want to have my translation vector to be a nice even number. I'm going to set a point, and let's say you want to put the point to be basically where you want the origin to be. So basically in the middle of your site. So in this case, I'm actually going to go to Layers panel here. I'm going to delete all these excess layers that is produced when you make a new file. I'm going to layer and call this one origin. Make that my default layer, then set a point. And I'm just going to set that point to be like somewhere in the middle. Let's say in the middle of the former Rams Stadium, the America Center Stadium, for instance. And I'm going to set that point in Grasshopper. Set one point, Grasshopper. The only reason I do this is I want to see the coordinates. So if you deconstruct that point, you can see the x and the y coordinates of that point, and also the z as well. But the z is probably going to be 0, which is, yeah, 0. So what I'm going to do is I actually want to take this number here, and you can just straight up copy this number and remember this as your translation vector, but I don't like all these decimal points. So what I'm going to do is I'm going to just clean up the coordinates a bit. So I'm going to round those numbers by typing round, plugging x to the round value, plugging in the y to the round value. If you see the result, you have a nice clean integer. And then what we're going to do is we're going to construct a point using that new x value, that new y value, and since z is 0, we don't need to do anything to that z value here. And if I zoom in here, you'll see that this is the new point that has removed all those points. So then just bake that, and then delete the original point. So now if you set that as your point here, you'll see that the x and y numbers are now nice, clean integers. So what you want to do now is you want to lock that origin layer, because you don't want that point ever to move, because you want that point is going to be basically your keystone to how you translate the model. And then what you want to do is you want to set up some kind of text file. So I might just set a text file and call this one, just rename it to like translation vector or something. And then just remember those numbers. So let's copy the data from this, copy data only, go to that Word document or the text document, paste that in there, and then copy the y, paste it in there, and then 0 for the z, and then just save that. So now you don't need Grasshopper anymore. You have the point there. And now what you do is make sure the origin is locked so that doesn't move. Control A to select everything. Hit M to get the move tool. Select that point as their start point to move from. Then type in 0, 0, 0. Everything has moved to the origin except for that point. That point needs to stay at the point because that's going to be the location, the way we orient things back if you need to. Now you see your model is now at the origin. You can start to model things a lot cleaner and a lot more with less artifacting as a result. And so we'll end that video here, and we'll continue the next half. And